Hi students, in today's video we are going to discuss about operating system types. There are mainly several types of operating system. Uh, let's giving some example like batch operating system, then multi-programming, then multitasking, then multi-processing, then our real-time operating system, then our time sharing, then our distributed OS, then also mobile OS also. These are some operating system examples, and we are discussing some types also from them. First, we are going to discuss about batch operating system. Batch operating system. Okay. First of all, there is three components in batch operating system. One is our OS, and one is our programmer, then one is operator. Operator. These are the persons, and this is our system. Okay. Then here are some notes are provided. If you want to copy them, then you can copy also. Okay. I am discussing what happened inside the batch operating system. Programmer, this is programmer, gives many jobs, a list of jobs or several jobs to our operator. Then our operator sort these jobs according their requirements, according their actions, according their how they work, so which operations, according their similarity. They sort the jobs on their similarity, then give to the OS. Then OS execute the operation and give to the operator. Then operator send the output to the programmer. Okay. We are discussing again. There is mainly three parts. One is our programmer, then our operator, then our OS. Okay. Programmer give a list of or several jobs, means processes, to our operators. Then operators writing here give. Okay. Then operators sorts and send to the OS. Sort or sorting. Okay. Then after sorting, the OS will execute. Then after execute, the OS will give the output to the operator. Then operator send the output to the programmer. Okay. Send the output to the operator. This is the simplest mechanism of batch operating system. Okay. In batch operating system, there is no introduction of CPU scheduling or process scheduling. There is CPU scheduling and process scheduling not introduced in batch processing systems. Okay. Here are some notes. Okay. Then here the operator would sort programs into batches with similar requirements, and the computer became available would run each batch. Okay. A batch means similar types of jobs. Okay. Then the output from each job would be sent back to the appropriate programmer. Okay. Who sent the operator sent? Operator sent the outputs to the programmer, and operator took the output from the system. Okay. Then these are some systems. The memory layout. Here is our operating system. Here are user programming area, user program area. Then here is our simple diagram. One is blue jobs, means blue color, similar types of jobs in blue field. Then another similar types of job in green field. Then another types of jobs in this field, and another jobs in gray field. Okay. These are interacting with our OS and hardware. This is our batch operating system. Then advantages. Okay. What are the advantages? Advantages is these are automatic. Okay. One operation is executed automatically after another. Okay. Then written batch processing system is particularly useful for operations that require the computer or peripheral device for an extended period of time. Okay. That means if you are discussed that there is a input output operations, there is input output operations for multiple processes. Okay, then multiple processes of input output operation related to input output operations will be run for a for some time. Okay, and this is saying that, okay, at a time uh, we have completed our all the processes related to our IO operations. Okay, then increased performance as it was possible for job to start as soon as previous job is finished. Okay, I already told that if one process is completed, then another process is done automatically, is executed automatically. uh, this point mentions that. Then here another priorities can be set for different batches. Okay, here's some example. Okay, I can prioritize them. If I tell prioritize blue first, then this one, then this one, then this one. Okay, this can also happen inside our batch processing. Okay, then there is disadvantages. No interaction is possible with the user while the program is being executed. Okay, what is telling that while the process is executing, the user can't access, okay, or interact with the program. This interaction only happens in our time sharing or real-time operating system. Okay, no other operating system can handle this type of interaction. Okay, this is a crucial interaction because interaction with user interaction of user with the program during execution, this is not a simple, this is complex, and this is only available in our real-time OS or our time sharing OS. Okay, let's move to our next point. In this execution, the CPU is often idle because the speed of the mechanical IO devices are intrinsically slower than. Okay, here is another thing that is the disadvantage, that if processor P0 if process P0 is executing and it needs a IO operation, it need to be IO operations or IO input output needs something, and then the CPU will wait and sit idle until the processor P0 get the input output operations or input output values. Okay, here is a main disadvantage. It takes too much time. Okay, because the IO device is very much slow. Okay, then here is our multi-programming system. There is a multi-programming system. Okay, I am giving the summary of processing system. That there is multiple programs inside our memory. Okay, this is our memory. Then maybe this is our P0, process P0, then P1, then P2, then P3. Okay, there are mainly four processes inside our main memory, but executing is one. But CPU is executing only one processes. Okay, then here is also one thing that we have mentioned in our batch operating system, and thus the CPU is remain idle while it need our some input output things during the execution. But in multi-programming operating system, if the process needs some input output operation or needs some extra things, then it will go to the waiting stage. Then after waiting stage, it will another process will be mapped to our CPU. Okay, then the most discussing the point, the most important aspect of the job scheduling is the ability to multi-program. Okay, multi-program. Okay, and here another thing, job scheduling is introduced. Our CPU scheduling, disk scheduling, process management, all these are introduced in multi-programming system. Okay, then multi-programming increases CPU utilization by organizing the jobs so that CPU always has one to execute. Okay, and simply saying, the CPU is never idle. In our batch processing system, the CPU is idle during the process is waiting for any IO result. Okay, or IO input. But here, if it is waiting for IO result, then it is simple. The process will be goes to waiting stage, and another process will be switched to the CPU. Okay, then here the idea is follows. The operating system kept several jobs in memory simultaneously. The set of jobs is a subset of the jobs kept in the job pool. Okay, but there are different jobs inside the job pool. Okay, this is the number of jobs that can be in the job pool. A simple saying that there are multiple jobs in our job pool, and there may be a subset of these jobs. When there is a complex job, and the one complex job is broken into several multiple smaller jobs. Okay, then the operating system picks and begins to execute one of the jobs in the memory. Okay, simple thing, one of the job, only one will be executed from the memory. There may be multiple jobs inside the memory, but one will be executed. Then eventually the job may have to wait for some task such as an IO operations to complete. Okay, if the job may to wait for some task, then in a multi-program system the OS simply switches to and execute another job. Okay, if a job is waiting for any IO operations, then the OS will simply switch that to another job. Okay, when that job need to wait, the CPU switch to another job, and so on. Eventually the first job finishes waiting and gets the CPU back. Okay, first it get the IO result, and then it will go to the CPU to execute. Okay, as long as at least one job needs to be executed, the CPU is never idle. Okay, the CPU will be never idle. Okay, simple, that is saying. Then multi-programming is the first instance where the OS must make decisions for the user. Okay, what decision? I just told you that CPU scheduling, job scheduling, all these are happening here. All these processor, all the CPU scheduling and process scheduling, all these are introduced here. Means simple, you can write that CPU scheduling is introduced here. Introduced means first time CPU scheduling is introduced here. Okay, these are these points I have told in. Okay, and then here is some diagram. Okay, there is several jobs in the main memory, and operating system is also inside the main memory. Then this is a diagram that program B is in execution in process, and process A is waiting for the IO data of peripheral devices. Here is some states, that is ready state, means the processes are in ready to move for execution. Okay, and then after running, the process will terminate. If it wait for any input output operation, then this will wait in blocked state, then go to ready state after get the IO request or IO data. Okay, not the IO request, the IO data. Okay, then there is multitasking OS. Okay, multitasking OS. Simply describe me. There is a main memory. Okay, there is different processes like P0, P1, P2, then P3, then P4, then P5. These are the processes and can be interacted with the CPU. Okay or not? Okay, in the multitasking OS, multiple processes can execute simultaneously. How this happens? P2 is executing right now, and then the user opens the P1, then suddenly the P2 came back and the P1 switched to the CPU. Okay, this sudden switching or this faster switching feels like the faster switching feels the user like the CPU is simultaneously executing multiple tasks. This is multitasking. Okay, a single user can execute multiple programs at the same time. Okay, multitasking is the system's capability to work one or more than one job process at the same time. It means that whenever a job need to perform input operation, the CPU can be used for executing some other job or process that is also residing in the system. Okay, same thing. If the process wants some IO operations, then it may be go outside and wait, or go to the waiting stage, and another process is switched to the CPU. Okay, simple thing, not a rocket science. Okay, then the term multi-programming is used for multi-user systems. Okay, we are now discussing about the previous OS. Multi-programming OS is telling that used for multi-user systems. Okay, systems that are simultaneously used by many users, such as mainframe and server class. Okay, while different users are using a system at a time, in that system we using multi-programming OS. Okay, then the term multitasking is used for single user system. Okay, the multitasking is used for single user system, systems that used by only one user. Single user means single user system, systems that used by one user at a time, such as personal computer, notebook. Okay, then let's continue our multitasking. The multitasking is method of processing the multiple tasks concurrently in a single user system. How the concurrency implemented, I have already discussed that actually the CPU is executing one process. The CPU is executing one process, but when the user switching the windows, also the CPU, the OS is switching the programs or the processes. Okay, here is some example. You can read this example. Okay, you can read this example. Then there are actually two types of multiprocessing. One is multitasking. Two types of multitasking. One is cooperative and one is preemptive. Okay, we will again discuss preemptive types in our CPU scheduling. Okay, you can visit the video of CPU scheduling in this channel. Okay, a cooperating multitasking means a process inside the CPU or during the execution can voluntarily leave the CPU, not forcibly leave the CPU. Only if it wills, or if it wishes, or it finished its work, then it will leave the CPU. Okay, it can't be forced out. Okay, in preemptive, if a process is executing inside the CPU, then it may be forced out. Okay, means we can just took out the process from the CPU, or deallocate the CPU from the process forcibly. Okay, then the types of multitasking here I have discussed. Okay, cooperative multitasking and preemptive multitasking. Okay, then move to next part. Here is some multi-programming and multi-processing multitasking, our differences, comparisons. Okay, simple, nothing much. Then our multi-processing. Okay, if you want to write these points, then you can write. Okay, I think I have already defined all this, so this is not a difficult to understand. Then multi-processing or parallel OS or tightly coupled system. This is multi-processing OS. Okay, this is multi-processing OS. What is multi-processing OS? A multi-processor system. First, you have to read most systems, so that are single processor system, that is they have only one main CPU. However, multi-processor systems, also known as parallel system and tightly coupled system, are growing in importance. Okay, this is not a point. Okay, you have to first understand what is multiprocessor. This is multiprocessor means multiple microprocessors. Okay, in this system, in this multiprocessing OS, multiprocessor systems means multiple microprocessors. Okay, not multiple genuine processors. This mainly refers multiple microprocessors. Okay, then here simply saying that multiple microprocessors share a single system resources. Means a common bus, maybe a common memory, or maybe some common peripheral device, or maybe some common clocks. Here is also written the points. Such systems have more than one processor in a close communication, sharing the computer bus, sharing the computer bus, then the clock, then the memory, and common peripheral. These all are common. Okay, the computer bus is common, the clock is common, the memory is common, and the peripheral device is common. Okay, then here is some advantages. One is increased throughput, because multiple processor are doing that. Multiple processor will do work and execute faster, so the throughput is obviously increased. Throughput means our output. Okay, throughput means our output. Okay. Then our economy of scale. Okay, you can read the point. Multiprocessor systems can save more money than multiple single processor system. Okay, simply that if you are using multiple systems with a processor, with a single processor, it will be costly than a single system with multiple processor. Okay, simple telling that it will be costly if you are using multiple systems with a single processor than if you are using a single system with multiple processors. Okay, then third point, increased reliability. Okay, this is increased reliability. How the reliability is increased? When one processor failed to execute, then another processor will be mapped to this process or the program. Maybe the processor time is slow, but processor speed may be slow, but this don't fail. Okay, if one processor is failed, then another processor will handle the task. Okay, the system 100ly don't fail. Okay, simple. And this is called graceful degradation. Okay, graceful degradation means if we are if our one processor failed, we are giving those processes to another processor. Maybe there is a decrease in the performance, or due to excess processes, or due to more processes. This is called graceful degradation. Okay, then a system designed for graceful degradation are also called fault tolerant. Okay, fault tolerant means handling the fault. Okay, handling the fault. Then types of multiprocessor systems. One is symmetric, another is asymmetric. First I am telling about symmetric. Okay, symmetric means all the microprocessor in the system can able to execute all the tasks, all different types of tasks. Okay, there is nothing specific. Okay, all the processor execute all the tasks in symmetric multiprocessing. But in asymmetric multiprocessing, there is a issue. What is the issue? In asymmetric multiprocessing, only specific process can execute specific tasks. Okay, this is a CPU. Okay, this is a CPU. It will only execute the additions. It will execute only addition. And there is another CPU, another microprocessor. Maybe this is the microprocessor. Okay, this will only execute the division. Okay, these are, each processor is dedicated to their work. Okay, this processor can't divide and this processor can add. Okay, this is asymmetric nature. Okay, here I described about symmetric processing and asymmetric processing. You can write these points in your notes. Then let's move. This is our real-time OS. This is our real-time operating system. Okay, simple. In real-time operating system used in this application where the application need immediate response. Okay, the application need immediate response. The application need response in real time immediately. Okay, the real time operating system is an operating system intended to solve real time applications. Okay, real time applications and live application. Okay, I will want to give some examples. If you have ever noticed in the news channel that there is a batch or level written live. Okay, there is a level written live, live. Okay, what does it mean? What is happening in the camera is also in real life. Okay, happening in the real life in the same time. Okay, this is live. Real time applications mean live applications. Okay. That process data as it comes in, typically without buffer delays. Okay, no delay in the response. No delay in the response. Here is real-time operating systems are generally special purpose once designed to run embedded or specialized system. Okay, what is embedded system? Embedded systems means there are embedded means packed. Okay, embedded means packed. There are multiple systems packed inside a system is called embedded system. Okay, the systems often operate in environments where there are significant constraints on hardware design and often narrow tasks and need to be done with a great accuracy and speed. Okay, to do this, to do with great accuracy and speed, we have to communicate with the live data, with the real time data. Okay, so it is called a real time operating system. Real time systems are used in military, engineering, medical, and data communications and systems. All this. Okay. Let's discuss some example in medical sector that when there may be automatic system when the blood pressure of the patient increase, that time maybe there is the increase in flow of the saline. Okay, this is automatic. How the flow of saline, the flow of which the controller which control the flow of saline will interact with the BP machine. Then in the real time the speed will be controlled. Okay, that's like example is a real time operating system in air traffic control system, the network multimedia systems, command control system. These are the examples: military, engineering, medical, data communication, all this. Okay, and now our IoT devices also have our real time operating systems. Okay, what is the advantage? Advantage are better throughput, output is better, then time taken for response time is less. Okay, if the time taken is more, then it may be fail, and then very costly because you have to interact repeatedly and there is many more components, machineries needed, then large memory required. Same reason, continuously interacting, continuously responding, all this needed more memory. Okay, then our distributed operating system or loosely coupled operating system. Now I can simply tell that a processor communicate with each other through various network line and multiple central processor used by distributed systems. Okay, what does it mean? First you have to let us watch our notes. Okay, distributed operating system is one of the important type of operating system. Okay, then multiple central processors are used by distributed systems. Okay, what does it mean? Now multiple processors are distributedly. Okay, to solve multiple real-time applications. What is it describing? Multiple central processors, okay, works on multiple real-time applications, on multiple data and multiple respondents. Okay, data processing jobs and distributing among the processes. Okay, I just gave you some example like in medical. Then if I will add or integrate multiple systems like that in a single system, then this is called distributed system. Okay, processor communicate with each other through various communications lines. Okay, processors communicate with each other through various communication lines. These are also known as loosely coupled system or distributed systems. Okay, processor in this system may vary in size and function. They are referred as sites, nodes, and okay, what is telling? Now, processors in these systems may be vary in size and performance and functions. Okay, there may be different processors may be included in our systems. Okay, these are some advantages. With resource sharing facility, a user at one side may be able to use the resource available at another. Okay, simple telling that one user can send the data to another through direct or indirect paths. Okay, then speed of the exchange of the data with one another by electronic mail. Then failure of one side is distributed system does not affect the other. Remaining sides can potentially continue operating. Okay. What does it describe? If A is transferring through B and C to D, then if the B fails, then there is another route that A can send to the D. Okay, but if there is a failure inside the A, then this can't be recovered. Okay, then better service to the customers, reduction of the load on the host computers. Okay, reduction of the load is genuine because there is other options. If only one option, there is a pressure or a load on the host computer. Then reduction of delays in the data processing. Okay, if there is traffic in one route, there may be delays. Then we can change another traffic. So there is a reduction in delay. Okay, these are there is another time sharing operating system. Okay, what is time sharing? Multiple computers. Simple time sharing means multiple systems or computers can share their resources simultaneously on a common clock. Okay, how a time sharing systems allows many users to share the computer resources simultaneously. In other words, time sharing refers to the allocation of computer resources in the time slot to several programs simultaneously. It's simple. Multiple computers can share their resources simultaneously. These are some notes. If you have to write, then it is easier. Okay. Here is some multiple user, multiple computer sharing their resources simultaneously, and the CPU is interacting all the resources. Okay, this is our types of OS, and thanks for watching this video.